8 simple math problems that no one can solve. 1. The Colot's conjecture. Take any whole number. If it's even, divide by 2. If it's odd, multiply by 3 and add 1. Keep repeating these steps. Every number tested so far ends up at 1. Mathematicians have tried millions of numbers, yet no one can prove this works for all numbers. Some think a very large number might break the pattern. Others believe it might create an endless loop. 2. Moving sofa problem. A simple real-world problem stumps mathematicians. What's the largest sofa that can turn a corner? The sofa can't bend or be lifted. The corner is exactly 90 degrees. This creates a number called the sofa constant. It lies somewhere between 2.2195 and 2.8284. After decades of study, the exact number remains unknown. 3. Pi plus e problem. Pi and e are famous mathematical constants. We've studied them for centuries. We know both are transcendental numbers. That means they can't be solutions to simple equations. But when we add them together, strange things happen. No one knows if pi plus e is transcendental. The same goes for pi times e. 4. Large cardinal problem. Infinity comes in different sizes. Some infinities are bigger than others. Mathematicians keep finding larger ones. They create a growing ladder of infinities. Each new discovery breaks the previous record. No one knows where this ladder ends. 5. Goldbach's conjecture. Every even number bigger than 4 can be written as the sum of 2 prime numbers. Take the number 18, it's 13 plus 5. Or look at 42, it's 23 plus 19. This pattern works for every even number we've tested. Computers have checked billions of numbers, yet mathematicians can't prove it will always work. 6. Inscribed square problem. Draw any closed loop on paper. The loop can't cross itself. Mathematicians believe a perfect square exists. This square would touch the loop at exactly 4 points. It works for some shapes. It seems to work for all loops tested, but no one can prove it works for every possible loop. 7. The unknotting problem. Mathematicians study knots like the ones in shoelaces. They can prove when some knots are different from others. They've created algorithms to untangle knotted strings, but these algorithms get very slow with complex knots. No one knows if faster solutions exist, or if the slowness is an unavoidable part of the problem. 8. Twin prime conjecture. Some prime numbers come in pairs, like 11 and 13, or 599 and 601. They're always 2 numbers apart. These pairs get rarer as numbers get bigger, but they never seem to stop completely. Scientists think there might be infinite pairs. They've been searching since 1849. The closest they've come is proving pairs 6 numbers apart. That final gap from 6 to 2 remains unbridged.